Here we are going to talk about the rules of exponents. So as a reminder, when you were really tiny and small and stuff like that, you had something that looked like this. And you added all those up. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. Right there. And then you got a little older and they said, hey, 2 was added to itself 5 times. And so they said 5 times 2 was 10. And that 5 measured how much addition happened. This is one way of defining multiplication as repeated addition. Now we have 2 times 2 times 2 times 2 times 2 times 2. We get 2 5 times again. But now it's repeated multiplication, so we put the 5 right there and we say this is 2 to the 5th power. Gives us 32. Now with this, just like the multiplication tables were valuable when you started learning addition and just use the distributive property, you started using them over and over and over again. And memorizing it became imperative, so you didn't have to go back to the old way of doing things to get to 5 times 2 is 10. The same way here, you really should memorize the squares, like 1 squared equals 1, 2 squared equals 4, 3 squared equals 9. You should do that all the way up at least to 16 squared. 17, 18, they're kind of nice, but 16 squared is really important, and 20 squared should be able to do that one. Should be able to do 25 squared as well. Then these are just the squares. So that's 16 times 16, 3 times 3, 2 times 2. You should also be able to do the, 1 cubed is 1, 2 cubed is now not 6, but 2 times 2 times 2 is 8. And 3 to the 3rd power is 27. You should memorize all of those cubes up to certainly 9 cubed is 729, and 10 cubed is 1,000. That's 10 to the 3rd power. 8 cubed is 512, 7 cubed is 343, 6 cubed is 216, 5 cubed is 125, and 4 cubed is 64. You should memorize those. Then the 4th powers, certainly the 1, that guy. 3 to the 4th is 81, which is the same as 9 squared. And then 4 to the 4th is 4 squared, 16 squared, which is 256. We should write these down. And then you should do the 5ths for 2 to the 5th and 3 to the 5th. The 6th, you should definitely do 2 to the 6th, 2 to the 7th, and 2 to the 8th for good measure. These are kind of the exponents that you really need to memorize. So commit those to memorization. You'll need to do them. We are now going to go through, and over on this side over here, we're going to find out what happens with exponents, how you add, subtract, multiply, and divide them. So when we multiply two things, they could be any numbers, 2s, 5s, 8s, or 9s. We're going to do it with x's because they're so often used. When you have an x squared and you take and times it by x to the 7th, you end up, that guy means xx. This guy means 1, 2, 3, 4, 5, 6, 7. You have 9 of them right now, all times together, so we mark it like that. Gives us the rule that goes over here. When you are multiplying things with the like basis, so you can combine them all into one thing, you add the exponents. That's the first one. Now, what happens when you take x to the 7th and square that whole thing? You've got an exponent already, and you're taking that expression to another exponent. What happens there? This is where you get, well, let's see what that means. This means x to the 7th squared, which means you times it by itself. According to this rule, that better give us 14. So that's what we do. This rule is when you are taking an expression with an exponent to a power, you multiply. What if we have an x to the 7th divided by x squared? Now in slow motion, we have 7x's up here, 6, 7. We have 2x's down there, and this is division, which means those two multiplying and those two multiplying divide to 1, or commonly called canceling, leaves us with 5 up here. You're like, hey, I know how you take 7 and 2 and get 5. Yeah, when you're dividing, these guys subtract. Now, something very interesting about the subtraction. When subtraction begins coming in, it's possible that you may get x squared over x to the 7th, which that's going to come out to be x to the negative 5 if you follow this rule. 2 minus 7 is a negative 5. You're like, a negative exponent? What in the world could that mean? I mean, exponents over here, it meant 2 to a certain number of times. How could you have 2 to a negative number of times? Well, if you remember way back when we started discussing the number sets, negatives mean other direction. And that's exactly what happens here. The other direction from multiplying something is dividing it. Well, let's do this in slow motion. You'll see exactly what this is. This is xx over xx, 5, 6, 7. Whoosh, whoosh. Well, when these cancel and leave a 1 up here, this equals 1 over x to the 5th. This is what a negative exponent does. Negative exponent means you flip it. If it's up here on the top, it goes to the bottom as a positive exponent. If it were on the bottom, it would flip to the top, because when you divide by a fraction, you end up multiplying by the reciprocal. So it flips it like that. This warrants just a couple of different things. So like let's go over to this, what we have here. That means 2 to the negative 5th power equals 1 over 2 to the 5th is 1 over 32. And that is correct. If you want to try that in your calculator, 2 to the negative power, you will get a decimal, a very small decimal. And if you turn that decimal into a fraction, it will be 1 over 32. Go ahead and give it a try. But a negative exponent means you're down on the ground. It's great. Okay, so this brings us to the next little rule of exponent that we have, and that is if you have something to the 0 power. Initial reaction to that is, hey, that's 0, because we've got none of them. But notice that this is the same thing as if we had x to the 7th over x to the 7th. If you subtract exponents, you might get a 0 up here. The only way to get a 0 is if you have the same exponent there that you are subtracting. Well, we know that that equals 1. And so, indeed, anything to the 0 power equals 1. This warrants a little bit of messing around over here with the 2's. I'm going to do this. 2 to the 4th equals 2 cubed equals 2 squared, 2 to the 1st, 2 to the 0, 2 to the negative 1, 2 to the negative 2, 2 to the negative 3, 2 to the negative 4. That should be enough to establish our pattern. 2 to the 4th is 16, 2 to the 3rd is 8, 2 squared is 4, 2 to the 1st is 2. Let's skip that guy for right now. That's 1/2. This is 1 over 2 squared, so 1 over 4. This is 1 over 8, and this is 1 over 16. Notice, these are exactly reciprocals of these numbers up here, which is what the negative exponent does. It flipped these all the way down to the bottom. But look at this pattern. If we take this and divide by 2, we get 8. Well, yeah, 2 to the 3rd times by 2 will give you 2 to the 4th, so dividing by 2 will give you 8. Dividing by 2 again will give you 4. Dividing by 2 again will give you 2. Dividing by 2 again will give you, ta-da, the number 1. Divide by 2 again, you get 1/2. Divide by 2, divide by 2, divide by 2. And this happens with every number. If we took 3 to the 4th, we'd get an 81. Then a 27, you divide by 3. Then a 9. Then a 3. Then a 1. Then a 1/3 and a 1/9. And it works every time. Anything to the 0 power is 1. And then, of course, anything to the 1st power is just itself. And the final rule for exponents, we're going to look at what happens when we have a fraction in the exponent. Now we know that if we did this, x to the third to the 1/3 power, by this rule right here, this multiplication, this power to power, we're multiplying. So we get x, 3 times 1/3 is 1, which equals x. We also know that if you take x cubed and you cube root it, you better end up where you started with, which is x. So now we have what a fraction does. A 1/3 power on something is really the same as a third root. If I have x to the 5 halves power, that really means I'm taking the square root of x to the 5th power. So now that we have those rules, let's make sure we understand a few of these. If I take 36 to the negative 3 halves power, the way this works is we're going to take the square root of 36, which is 6. Then we're going to cube it, which is 216, and then put it on the bottom. So this is 1 over 216. Let's try another one. 32 to the 4/5 power. Again, that's your root. That right there is the power. And then that one flips it. So 32, when you fifth root 32, you get 2. And you can see that right over here. 2 to the 5th is 32. So 32, when you fifth root it, will get you back to 2. 4th power, 2 to the 4th power is 16. So that's 32 to the 4/5 power. Let's do something like 27 to the 2/3 power. Cube root of 27 is right there. 27 cube root is 3. Squared is 9. And if you happen to put a negative on it, that's 1 over 9. Good. That should give you some experience to be able to do the exponent monsters. So in this, we get special numbers that are squares and special numbers that are cubes and fourths. This allows us to simplify.